this thing. So yet another question where you have to use difference of squares formula, right? And we've seen those a few times now. How would we approach that first question?
21 minus.
And 121 plus 21, right? Which makes it 100 times 142, right? And multiplying by 100 is really easy. You just add two zeros. So, right? Are we getting a little better at this? All right, well, I'll keep giving it to you till you get it. All right, this is just a straight up formula. So when you plug everything into the formula, you should end up with x squared plus double product, so it's 4x double, so 8x plus 16. Right? And how do we factor this thing?
2x plus 5, 2x minus 5.
Right, so that's the difference of squares formula. 2x plus 5, 2x minus 5. And that's it. That's the quiz. Okay, good. So at this point, we have 5 formulas. So the formulas that we know. So our difference of squares formula. Our square over sum formula. And the square over difference formula. And then we've got 2 more formulas on last, what was it, Thursday? And these are the formulas that I will be giving to you when needed. You don't have to have them memorized. You just have to know that they do exist. I need to know how to apply them. So the top 3, you owe me this one. Right? You need to know the top 3 formulas, and I will be giving you all the cubic ones. So we have 2 formulas left. And really, the last 2 formulas, we only use them for factoring. Very rare we use them to multiply. So one is called difference of cubes. And it is a cubed minus b cubed. I'll tell you what it equals to, then we'll check by foiling. So we use this to factor. So the first parenthesis has a minus b in it. And the second parenthesis actually has a trinomial, a squared plus ab plus b squared. No matter how hard we try, we will not be able to factor the trinomial a squared plus ab plus b squared. You're always going to be stuck with that. You won't be able to reduce it. As you see, it's very close. That trinomial is very close to our square root of sum formula, just missing a 2 in the middle. So sometimes it's called a degenerate trinomial. It just didn't get the 2 in the middle. Cannot go any further, but this is as far as we can break the difference of 2 cubes. Now just to quickly check, see if I FOIL the right-hand side, I should get the left-hand side. So if I do that, a times a squared is a cubed. A times ab is a squared b. A times b squared is ab squared, right? Multiplied by a. Now multiply by negative b, we get negative a squared b, negative ab squared, and negative b cubed. So all those things in the middle cancel. And we're left with a cubed minus b cubed. So that's how you check whether the formula is true. Okay, so again, you don't need to memorize that formula. I'll give it to you. We'll practice on using it. So I have difference of cubes formula, and we do have sum of cubes formula. A cubed plus b cubed factors into a plus b, and then a squared minus ab plus b squared.
What test is it again? I was just tried 3 times.
Were you here on last Thursday?
Oh, is this for now last class?
Yeah. But I probably have year 1 and 2 in my office.
Yeah, probably.
So again, the reason why I don't require you to memorize this, because they're just random pluses and minuses, and it's hard to keep track of them. Again, we can check this by foiling. If I foil the right-hand side, I should get the left-hand side. So if I do that, a times a squared is a cubed. A times negative ab is negative a squared b. A times positive b squared is ab squared. And then multiply by b, we'll get positive a squared b, negative ab squared, and a positive b cubed when we foil.
That is a sum of the cube?
Yeah, so it's a sum of cubes, right? So yeah, the middle thing's cubes. So yeah, that's sum of cubes. Okay, so these are our 7 formulas. You need to know top 3, and you need to know how to use bottom 4. Okay? I will be giving you the bottom 4. Joe, get your quiz 3. I think that's yours. Did you get your quiz? No, you're good. Anyone else? On Thursday? Okay, so let's practice. I'm going to do a few examples using these formulas. So again, the cubic, the 6 and 7, the difference of cubes and the sum of cubes, we use them to factor. Okay? Very rare you use them to actually multiply. It's really hard to notice that pattern. But for factoring, they work really well. So here's an example. You're asked to factor the following expression, x cubed plus 8. So we first have to recognize that this is in fact a sum of 2 perfect cubes, right? And you just have to match that with our sum of cubes formula. So just identify what A is and what B is. Well, what is A?
X.
Just x, right? So the cube is there, so A is x. Well, what is B? What is being cubed here? 2, right? I mean, silently, I don't have to write this down. I think of this problem as x cubed plus 2 cubed. So x is my A, and 2 is my B, right? So then I'll just plug everything into that formula. That formula says, well, add A and B. So then it's just x plus 2. A plus B is x plus 2. And then it says go a squared, so that's x squared, minus ab, so that's minus 2x, and then plus b squared. So in our case, it's 2 squared, so plus 1. And that's it, we're done. There's nothing else we can do. You will never be able to factor this quadratic. Even if you try very, very hard for a very long time, it won't factor. Okay? we'll just have to invent a whole new numerical system to factor that. So for now, that's it. Does that make sense how we use that? The second you identify that A equals X and B equals 2, just plug for every A you put X, for every B you put 2. And it just pulls out. Okay? These are really hard to factor without knowing this formula. Almost impossible. You have to get very creative to factor sums of cubes without hitting them all. So any questions on that? So if you have the formula in front of you on the test, on the quiz, just use it. Just need to know how to use it. Okay, let's do another one. 27x cubed minus y cubed. Again, we have to realize that we're looking at the difference of two perfect cubes. And what is being cubed in the first place? 3 and x, right? So I can think of this expression as 3x cubed. Right? So 3x will be playing the role of a in my formula. So 3x is my a. While y cubed is y cubed, so y is my b. Is that okay? So how we identify a and b, we just kind of see what's cubed in the first place, what's cubed in the second place. And since we have a minus in between, we'll be using the difference of cubes formula. So that's the first one I gave you, right? The a minus b, so forth. Okay? So if we use that formula, it tells me to first write a minus b so a minus b would be 3x minus y. Is that okay? So that's a minus b. Then the formula, I cannot scroll up, but you see it in your notes, tells me take a square a. So what is a squared? 9x squared plus ab, so 3x times y is 3xy, and then plus b squared, so then it's y squared. And we're done. There's nothing else to do there. So again, this is my little formula. A minus b, a squared plus ab plus b squared. How's that? Is that okay? So it helps us to factor, which means it will help us to solve equations. Cubic equations are hard, but this is all of a sudden that's a linear and that's a quadratic, and we can always deal with linear and quadratic really easily. Okay, let's try another example. X cubed minus y to the power 6, and I want to factor. So which formula do you think we're going to attempt using here? Difference of cubes. So first we need to realize that something is being cubed in the first place. Well, that's easy. What's being cubed in the first place? X. And that something is being cubed in the second place. Well, what's being cubed in the second place? Y squared. Very good. So I can think of this problem as x cubed minus y squared cubed. So y squared will be playing the role of b here. So I need to see those two cubes on the top, and then I can say that x is my a and y squared is my b. And the second that I recognize the value of a and b, I can just plug it into my formula. Since it's a difference, we go a minus b, so it's x minus y squared, right? And then formula tells me go x squared, so a squared gives me x squared, plus the product of a and b, so that's just x y squared, and then b squared. Well, b is y squared, and you square that, you get what? Y to the fourth. Just plug it into the formula. You know what's the good thing about factoring? You can always check your answer by foiling, because you're all good at foiling. So when in doubt, foil, see whether you get the original thing back. When you ask me, did I factor this correctly? Oh, that's just plain lazy. Foil, you'll get the thing back, right? So that's the nice thing about factoring. You can always check. And check takes what? 15 seconds to foil, and then see whether you come back to the original. But again, this was the formula. So for every a I put x, for every b I put y squared. So that's why we ended up with y to the fourth in the last place.
What do you do with y? I get the y squared and then to the third. Does the third power just kind of?
Yeah, the third power, it's there still.
It's there.
Right? If I foil it out, I'll get back to the original. So I still have the highest power of y would be in this product when I foil.
Okay.
Y squared with y to the fourth, that'll give me y to the sixth. Everything else will reduce. Is that okay? Well, let's try this one. X cubed plus 1. Is x cubed a perfect cube?
Yeah.
How about 1?
Yeah.
Yeah, 1 is perfect anything, right? I can always think of 1 as 1 cubed. So, really, there's nothing prevents me from thinking of this problem in those terms. So it's, that 3, I can always fake it. So what is the value of a here, and what is the value of b? Well, a is x, and b is 1. So I'll plug x for every a and 1 for every b, and I'll be using the sum formula. So it's x plus 1, a plus b, and then it's x squared minus ab, so just x times 1, that's x, and plus b squared, so just 1. We're good. And again, when in doubt, you can do a quick FOIL, and you should get the original problem back. That's how you check your factoring. Right? Good. All right, let's do a fun one. Are you ready? This is a joyful problem. I still want to factor. X to the power 6 minus y to the power 6. And here, all of a sudden, you have options. Because you can think of this problem as a difference of 2 cubes, right? Because I can always think of power 6 as something cubed. Or you can think of this problem as difference of squares. Because x to the 6th is x cubed squared. Right? Do you see that? Every time you see even exponents that could be interpreted as squares, every time you see exponents that are divisible by 3, it can be interpreted as cubes. So when faced with this situation, it's always easier to think of these problems as difference of squares first. It's easier to deal with the smaller exponent first. Okay? So if I do that, if I think of this problem as difference of 2 squares. So right now I see something squared minus something squared. So this is a difference of squares. How would we factor this just using a difference of squares formula, like you just did on your quiz.
X to the third plus y to the third.
Yeah. So one with a plus, one with a minus. So just using a difference of squares formula. A is x cubed, b is y cubed. Is that okay? So that's just kind of the first step. We recognize we have two squares, minus in between, so it's a plus b, a minus b situation. The very first formula that we learned. Now when you ask to factor, you should always slow down and think, can you go further? Well, in this case, when you look at the first parenthesis, that's just the sum of two cubes, right? And we just learned the formula for the sum of two cubes. So just without really any computation, we get that. The formula that we just discovered. Basically, a is x, b is y. So there's really nothing special going. So that was sum of cubes. And on the second one, we'll look at that one as difference of cubes. So x cubed minus y cubed will break into x minus y, x squared plus xy, plus y squared. So we end up with something like that. For parentheses.
So the answer would be that big thing at the bottom.
Yeah, that big thing at the bottom. Because again, those quadratics, the quadratics that are coming from the sums and difference of cubes formula, we won't be able to break them down any further. So we're done. So we have four parentheses. That little x squared minus 6, x to the 6th minus y to the 6th broke down in that unholy mess. And it's really hard to keep track of your signs. That is what it's true, right? You just
So you did sum of cubes and difference of cubes?
yeah, because I look at this first one, that's the sum of two cubes, and then I look at the second one, that's the difference of two cubes. But I started as a difference of two squares. I could have started as a difference of two cubes, and then I would get myself in a whole lot. I would get a really weird thing, and I won't be able to get that far without cheating or whatever. Is that okay? So yeah, so those sums of cubes and difference of cubes, we use them to factor. We can also use our second and third formula to factor. We haven't done that yet. We only used the square of a sum and the square of a difference to expand the parenthesis, but we never really went back, never really tried to factor. Because if you remember your factoring trinomials, so recall, just basic factoring, if I give you something like this, x squared minus 4x minus 12, will you be able to factor that? How do we factor things like that? I assume you know that. Basic trinomial factoring when there's no coefficient in front. What do you look for? Oh, I'm asking a group. But if you know the answer, please. Yeah.
X minus 6 and x plus 2.
Right. So how'd you get those two numbers?
I really just guessed.
Oh, you just guessed?
Well,
Anybody?
you could use 4 and 3, but they don't work with 12. Like, there's like some kind of special
Oh,
shorthand.
yeah, you have to get it to add to 12 and multiply to 4.
The other way around.
Or divide 12.
Yeah, multiply to negative 12 and add to, all right, you all have to go and review your factoring. I assume you know the basic trinomial factoring. So this is the product, and this is the sum. Oh, sorry, just negative 4. So you need two numbers that multiply to negative 12 and add to negative 4, which were negative 6 and positive 2. So automatically you get x minus 6, x plus 2. This is a friendly version of trinomial factoring when you don't have a coefficient in front of x squared. When we put a coefficient in front of x squared, that's when things get hard. What? That's easier? No, that's not easy. I mean, I can't even think of a problem on top of my head that will work. I have to try very, very hard. Oh, let me make one up. Let's see how.
Now we're just making stuff up.
Just making stuff up, I'm challenging you. I'm pulling your bluff.
What about like 2x squared plus 4x plus 4?
2x squared plus 4x plus 4. I don't even think that will capture. Well, you can pull out a 2, but that's about as far as you can go. What if I have something like this? I'm still not 100% certain that that will work. I think that will work. When I throw that coefficient in front, that's when your life gets basically ruined. You can trial and error your way out of this problem. That's an acceptable technique. It might take half an hour. This will require a lot of guessing, so the luck becomes an issue. If I put this question on the test, one of you just got lucky this morning. You just kind of made the first guess and, oh, it worked. While for some of you, it might be on the last attempt. Because if you want to trial and error your way out of this problem, I'm going to list all the options, and there'll be a lot of them. Okay? Just think, the first one is the product of two terms. So it could be x and 8x. It could be 2x and 4x. That's about it, right? While for negative 45, it could be 1 and a negative 45, or it could be negative 1 and positive 45. It could be 3 and negative 15. It could be negative 3 and positive 15. It could be 5 and negative 9, or negative 9 and, well, that's the same thing. Negative 5 and a positive 9. Is there anything else? I think that's it. Well, now mix match all the possibilities. So what is this? 1, 2, 3, 4, 5, 6, 7. 28 options. Alright? So the chances that you guess on the first one is 1 out of 28, and so there's luck. By the way, with 28 students in this class, chances are somebody will guess in the very first try. That's the expectation.
But none of those sum to 26.
Right, but that's where 8 kicks in. That plays a huge role. Alright? So trial and error, 28 attempts out of 28 students, one will get really lucky, on average. Okay? So that's not a fun thing to do. There is another method, and I remember, I think it came up in this class at some point, because we're really doing a backward FOIL here. So what we want to do, we want to multiply the first number and the last number. So the product of the first coefficient and the last coefficient, which would be negative 360. So the product is negative 360, right?
Then the factors of the add 26.
Yeah, and the sum
For the
is still the number in the middle, 26. So what I'm doing now, I'm looking for two numbers that multiply to negative 360 and add to positive 26. Can you think of two numbers that multiply to negative 360 and add to positive 26? So that will involve some other trial and error, but it's a little easier trial and error. So two numbers multiply 360 add 26. What?
36 negative 10.
That's right. 36 and negative 10. So positive 36 and negative 10 are those two numbers. Okay? So what we're going to do with those two numbers, we're going to do something very sneaky. We will rewrite that middle coefficient, the 26x, as 36x minus 10x. We will split the middle coefficient using these two numbers. So we will rewrite this problem as 8x squared plus 36x minus 10x minus 45.
Factor by grouping.
And then factor by group. Okay, so this is the more scientific, algorithmic way of doing this problem without doing a lot of guessing. Then you factor by grouping. Very good. So we'll take the first two terms. What is the greatest common factor in the first two terms? I don't think 8 goes into 36, does it? 4, right? 4x. So I can pull 4x out. That leaves us with 2x plus 9. Is that right? In order for this to work, we need to get another 2x plus 9 out of the last two terms.
Minus 5.
Yeah, pull out a negative 5. If you pull out negative 5 out of the last two terms, you'll get 2x plus 9 as well. So 2x plus 9, 2x plus 9 becomes a common factor, right? Because I have a multiple of 2x plus 9 and a multiple of 2x plus 9, so I can pull that one out. So I can factor the 2x plus 9 out. So if you pull 2x plus 9 out, what is left? 4x minus 5. So you have to review your factoring of trinomials thing, which is everywhere. If you have your own I Know book, it's there. If you just Google it, it'll just show up. You can find it, a little YouTube video, go over that. I assume your ability to factor basic trinomials, right? If you're in this class. So,
So we should be able to do what's on that left-hand side.
in that thing?
Yeah.
Oh, hell yeah. Yeah, this is called the AC method. I think that's called, because it's this coefficient is A and that coefficient is C, and you multiply them, and this is kind of. I mean, you can still trial and error your way out of this problem, but it might take a while, because I can get really messy with the numbers. So you need to know this. So recall, this is the assumed knowledge. Okay? So review your factoring of trinomials. But now, one thing you need to remember, when there is no coefficient, life is good. When there's a coefficient, it just goes down the toilet. This is basically the hardest version of factoring. You have to do that type of dissection and things like that. Okay? Now, there is a middle ground. If I give you a problem like that, I have it written somewhere here. If I give you a problem and ask you to factor, and it's 9x squared plus 30x plus 25, and ask you to factor that, you might feel, oh, I got a number in front of x squared, as a result, it's all going down the toilet. Okay? But, yeah, very good, because you recognize that you have a perfect square here and a perfect square there, right? So when you see that, you should get very excited and hope that it matches one of these formulas. Because look, I have a formula that starts with a perfect square and it ends with a perfect square, right? So the only thing that I really need to make sure that my middle term checks out. So remember, the middle term is 2ab. So if this problem were to work, what is the value of a would be? 3x. And what is the value of b would be? 5. And thus 3x times 5 times 2 equals 30x. Yes, this balances us to 2ab. If your middle term anything but 30x or negative 30x, it won't work. But since it's a 30x, it's a perfect match, automatically, without doing any further work, it's 3x plus 5 squared.
And what do you do if it doesn't match?
Then you have to go back to what I did
The
earlier.
guessing.
Yeah, the guessing thing and then AC method, all that. But if it matches, perfect square, so that's, you start hoping that the middle is that double product, that it matches. So anything 30 or minus 30 would work. So just if you had a negative 30, you would end up with a minus in those parentheses. Okay? So that's the good news. If you start with a perfect square and you end with a perfect square, you have to double check the thing in the middle. Okay? Because if this was 28, then I don't even know whether it would work. We'll have to try. How about this one? Yeah. Again, you recognize that the first, you start with the perfect square and you end with the perfect square. What is being squared in that last place? 10, and what else? B squared, right? That's that last term. Well, what happens if you multiply a by 10b squared and you double it? You get the 20? Yeah, so it matches the middle, right? A times 10b squared times 2 is 20 ab squared. Do you see that, the middle thing? I just have to make sure that the middle works. That the middle is that double product.
And then you know it's gonna factor.
Then you know it's going to fall into my formula. I don't have to do anything else. Double product of A and 10b squared. So if I multiply A and 10b squared and I double it, I'll get 20 ab squared. So then automatically it's A minus 10b squared. Because we matched our formula. Okay? And that checking the middle is just to be safe. Alright? Just to making sure. Because technically you can just go, okay, it's A and then minus it. So that's how you can use those two formulas to factor. When you see the match, then it's just the factoring is done for you. You don't have to do anything. So that's nice, right? If you can recognize that, hey, I'm staring at my formula in the expanded version, can I pack it all back inside the parentheses? Okay? All right. Good. So now you got all your 7 formulas. So, today's worksheet, I will start that worksheet on the board, and you will kind of stick with me for a while, and then you'll work the rest of it on your own. If you want to take a break, take a break. Yeah, it's a big one. Staple. If you flip to the page 3, where it starts for the question H, the 3H, I'll start from there. I'll do from 3H all the way to the end, and then I'll cut you loose and then you'll do it from the start. from the start, it's pretty straightforward. I'll use this, so just write on it. I don't have to write on the board. What is that? Exactly what it is. What do you think?
That'll work.
Yeah, put it this. Nah, it's weird. I don't like it. I'll go back to it. That will just save me a few seconds so I don't have to write the question. Alright. So these are fun. Because we've been dealing with that since the beginning of the semester and it's week 3 already. So the whole question 3 asks you to factor. So every problem on the third set of problems asks you to factor. And so is on the second one. It's mostly all factoring. But starting with h, things get a little tricky. So x plus 1 squared minus 25. So you're asked to factor. Okay? Well, there are 2 ways you can do that. You can expand the parenthesis, you can open up the parenthesis, combine like terms, and then factor. And in this case, it will work. But we can do it, and I'll probably do it both ways just to show you how that works. Don't write this part down. If I square x plus 1, what do I get? Tell me really fast.
That's one.
Plus 2x plus 1 minus 1. Come on. This is what you owe me. Right? So if you combine like terms, x squared plus 2x minus 24, right? No coefficient up front, so life is good. So we're looking for 2 numbers that multiply to negative 24 and add to positive 2. What are those 2 numbers? Multiply to negative 24 and add to positive 2. 6 and negative 4. Okay, so we're done. We'll just factor the problem. Okay? Now, in the guidelines to this problem, I'm asking you to use the difference of squares formula, which we haven't done. Right? We haven't used the difference of squares. We'll use something else. So if I'm using the difference of squares formula, look at this problem closely. The way we look at that is that I have something squared in the first place. Right? The first expression is a perfect square. So is the second expression. Isn't the second expression a perfect square? Yeah. So if I match this with the difference of squares formula, the a squared minus b squared, what is a? X plus 1. X plus 1 is a here. A equals x plus 1. What is b? 5. B equals 5. Well, the formula tells me a plus b, a minus b, right? So therefore, I can factor this into a plus b, a minus b, right? This is a, this is b, this is a, this is b. A plus b, a minus b, right? So what is the value of the first parenthesis if I combine like terms? X plus 6. What is the value of the second parenthesis? X minus 4. X minus 4. So that's what we got to do. But it's a lot faster if you recognize that you're dealing with a perfect square minus a perfect square. Just our a happened to be some much bigger expression than we used to. Right? Does that make sense how we broke that down? We just use the, a squared minus b squared is a plus b, a minus b. It's just a was x plus 1 in this case. Well, there are 2 more that are dealing with that. So you'll probably get it. I we have m plus 10 squared minus m minus 12 quantity squared.
So n plus 10 would be a, and n minus 12 would be
That's right. All I see that I have two squares with a minus in between. So I'll think of this as a squared minus b squared, where m plus 10 is my a. A equals m plus 10, while b equals m minus 12. And then I'll just use my difference of squares formula. Now in this case, I have to be very careful with my signs. So let's say the first parenthesis is a plus b. And I'm just, to be safe, I'm just going to put a little parenthesis around my terms. In this case, I don't really have to, but in the second one, I really do because of the minus. Because that minus, this minus right here, this minus, it will have to get distributed through that term. So it's really easy to lose that. But again, this is nothing but a plus b, a minus b, using a difference of squares formula. Now just simplify each parenthesis and we're done. We'll get some pretty large parentheses in the result. So it's m plus 10 plus n minus 12, and then m plus 10 minus n plus 12 when you distribute the negative. Right, so in the first parenthesis, nothing really happened, it just dropped the little ones. In the second one, distribute the negative. So combine like terms, m plus n minus 2, m minus n plus 22. So here we go. Nothing else you can do. You have two pretty large expressions. But it is factored. It's a product of two things. And I don't think this can be done any other way. If you actually open up the parentheses first, you get stuck with some mess. It'll be very hard to factor. So ask me questions about this one. So again, we looked at this as a difference of two squares, and we just plugged it into our formula and then simplified each of the brackets. So same thing is going on with j, 3x plus 1 squared minus 4x plus 3 squared. Again, that's a difference of two squares, where a is 3x plus 1, and b is 4x plus 3. So again, I can use the difference of squares formula, a plus b, a minus b. So I'll just do the same kind of thing to be safe. I'll put extra parentheses to make sure all my signs get distributed. So this is a plus b, a minus b. So in the first one, when I combine, when I get rid of all the little parentheses, I get something like that. In the next one, I just have to distribute the negative. I'll get 3x plus 1 minus 4x minus 3. all I did here is just distributed that negative. And then combine like terms looks like 7x plus 4, and then negative x minus 2, and that's okay, that's factored. What do you think of that? So again, as long as you see square, square, and a minus in between, what is being squared is irrelevant. Whatever's being squared becomes your A, whatever's being squared becomes your D, and you just shove it into your formula. As long as you have two squares with a minus in between. Okay? Good. So, divisibility question. Prove that 51 cubed minus 26 cubed is divisible by 25. Of course, without the use of your calculator.
25, 90, 36.
What?
51 minus 26 is 25.
Yeah, but the order of operations suggests that I cube first, right? So I cannot just do that. That's violating the order of operations, right? Doesn't have to work like that.
Right? Okay.
Well, if I write 51 cubed minus 26 squared, by your logic, it's still divisible by 25, but I don't think it is. Order of operation, I have to cube first, square first, and then something. So just because it looks like it might, it doesn't have to be. Now, what does it mean for something to be divisible by something else? If I ask you, does, is 35 divisible by 7? What?
Yes.
No.
25. Yes.
So which one is it?
Yes.
Oh, wait, yes.
Yes, 35 is divisible by 7. Why?
Because 7 can
7
go into
times 5 is 35.
Because you can write 35 as 7 times something else, right? So I can say that 35 is divisible by 7 because we can express 35 as 7 times don't care. Right? It's 7 times some other number, then it's divisible by 7. So if I can express 51 cubed minus 26 cubed by 25 times don't care, then this expression is divisible by 25. I can write it as 25 times some other number, right? Then it's divisible by 25. So, based on what we were talking today, 51 cubed minus 26 cubed, any of our formulas look like that. Difference of cubes. Well, using the difference of cubes formula, which is a minus b, a squared plus ab plus b squared, this expression, 51 is a, 26 is b, becomes 51 minus 26 times 51 squared plus 51 times 26 plus 26 squared, which is a ridiculously large number. But what is the value of the first parenthesis? What is the value of that first parenthesis? 25. So all I have is 25 times, I really lost interest in the second parenthesis. I don't care what it is. Don't care. All I know that this number, 51 cubed minus 26 cubed, can be written as 25 times something else. So therefore, it is divisible by 25. See that?
just be the answer at the end?
Yeah, so this is kind of it's a proof, so the answer is in the work. So when we do the proofs, and you finish with the proof, we like to write those three magic letters, QED. That means we're done with the proof. It's Latin for quod erratum demonstrandum, which means as needed to be shown. So that's a math speak for we've just finished the proof. Okay? Okay, good. That's fun. QED. Proving things. Okay, so that's all we had to do. But we couldn't just say 51 minus 26 equals 25 because we're violating a few rules. Because if I change those exponents, it doesn't have to work anymore.
Could you just leave it like another like 51 minus 26 with parentheses cubed?
No, because that's different. Then you're getting into this orders. 51 minus 26 cubed is different from 51 cubed minus 26 cubed. We have two different formulas for that. So those are not, so that will be violating the order of operation. You're just kind of subtracting and then cubing. So those are two different animals. All right, fun. No, that's a lot of pages. Okay. Question, part B. No, yes, 5A. What am I doing? 5A. Evaluate at a given value, I guess. So, a plus 3 squared minus a minus 2, a plus 2, when a equals negative 3.5. So we have two options. We can take negative 3.5 and substitute for a, and then compute whatever we get. Right? That's the idea. You know, you plug in negative 3.5 for every a and compute. Or we can simplify first and then plug in negative 3.5 for a, and that would be a lot easier. Because here you have to start squaring things, but maybe something good will happen. So in these types of problems, simplify first. I mean, you'll still get the answer. It'll be a lot harder. You'll definitely have to use a calculator maybe. But if I just simplify first, and believe me, one day I'll just give you a problem with some really nasty value for a, and you're really better off simplifying. So simplify first. So, how do you square a plus 3? What is it? Yeah, a squared plus
2a
Plus 3.
times
2, so that's 6a plus 9, right? So a squared plus 6a plus 9. Remember that 6a, you multiply a and a 3 and then you double it. Minus, is there a quick way to multiply a minus 2 and a plus 2?
Yeah, just share the first and last.
Yeah, so then it's a squared minus 4, and I'll still keep it in the parentheses because of the negative up front. So then I'll distribute the negative. A squared plus 6a plus 9 minus a squared plus 4. And look what happens. What is the good news?
The a squares cancel out.
A squares cancel out, and we're left with 6a plus 13, which is a much friendlier expression to substitute whatever you want to substitute for a. Any questions? How we got to 6a plus 13? Yeah.
Should it be negative 4?
Well, but this is why we kept the parentheses here, so that negative goes in and makes it a positive 4. Right? Because that negative in the original problem applies to everything to the right of it. So you have to make sure that that negative still applies to everything to the right.
Then we're not done.
We're not done. We still have to substitute. But now it's a lot easier. So we still need to evaluate. So substitute a equals negative 3.5. So So it's 6 times negative 3.5 plus 13. So it looks like, what is it? Negative 21? Well, negative 21, right? The first thing. Right, it's 3.5 times 2 is 7, times 3 is 21, plus 13, so yes, negative 8. You get the same result if you plug it in right away, but then you're dealing with decimals and you're squaring decimals, and it's just generally not the best, not the friendliest problem. Is that okay? So, you really get to appreciate the fact that you're better off simplifying first on the next problem. Because now substituting negative 2/3 in for m will cause a lot of pain. There is a fraction. And look at the coefficients in front of m. If those coefficients were multiples of 3, at least the denominator would cancel. But they're not. All right, if I just plug in 2/3 for m, 5 times 2/3 is, 10/3, who cares? It's still something awful, right? So you're really better off simplifying first and hoping for something good to happen. So let's simplify first. So 13 minus 5m squared. Using the formula, I need to take 13, square that, that's 169, right? 13 squared. Then, I'm going to multiply 13 by 5. What is 13? 65, and then double that. 130 with a minus, negative 130m. And then plus the last thing squared, which is 25m squared. So this is using the formula on that first set of parentheses.
I'm sorry, how did you get the 130m?
So we multiply 13 and 5, that's 65, and then double that. Okay. Now, on the next one, I have a minus, so I'm still have to be very careful. I'm still going to have parentheses. But I'm going to square first. So I'm going to take 12, square 12, 144. Minus 4 times 12 is 48. Double that, 96. M plus 16m squared plus 4. Is that okay? I can combine negative 30m with a 4m right away, and I can distribute the negative, but let's just distribute the negative and then we'll combine like terms. So distributing the negative gives me negative 144 plus 96m minus 16m squared plus 4m. So all I did was distribute the negative. So now let's start combining like terms. So 25m squared minus 16m squared. What's that? 9? 9m squared, right? Then we have negative 30m plus 96m plus 4m. Looks like negative 30m. Right? Because 96 plus 4 is 100, and negative 130 gives you negative 30. Right? And finally, 169 minus 144 is plus 25. Right? Remember how I mentioned? Oh, I can do things to this, yeah. But before before I go on, remember at the beginning I told you why this problem was awful? Because the coefficients in front of m had very little to do with 3. Because having a 3 as a coefficient will play really well with having 3 in the denominator. So that's why it was bad. But now look at the coefficients in front of m. 30 plays well with 3. 9 plays well with 3. But somebody wanted to take it further. How can you take it further?
Just factors.
Yeah, this is 3m minus 5 squared. So now it's really friendly. I only have one place to substitute negative 2/3 in, right? And that's what makes it quite awesome. You only have one real computation to do instead of few. So now substitute. And this is what we kind of talked about today. You have a perfect square, you have a perfect square, and then it matches in the middle. So we have 3 times negative 2/3 minus 5 squared. And it's really easy to multiply 3 and negative 2/3. What is 3 times negative 2/3? 3 is going to cancel. So left with negative 2. So it is negative 2 minus 5 squared, which is negative 7 squared, which is 49. Okay? That might have felt like a lot of work, but this is a lot of simple kind of work. Just opening up parentheses, combining like terms. You would be in a totally different level of pain if you just went in and substitute negative 2/3 into the original thing. You would still get 49, but it would be a total different level of computation. Yes?
I'm trying to, the 30m,
Yeah.
how'd you get that?
So 96 plus 4 is 100, right?
Yeah.
And 100, negative 130.
Yep.
Negative.
Oh,
Right? Because they all have m, so I'm just combining those two. And then we know that 30 is 2 times 3 times 5, so it matched our formula, and then you just plug it in, and we're good. Yeah? I like this problem. Again, for the fun of it, if you want to, plug in negative 2/3 in the original one, and see how far you can go. It'll be a whole lot worse than what we just did. And by the way, very good at noticing that we can factor further. We could have plugged it in here, it would still work. Just a lot easier when you only have one place to substitute. Okay? Good. This is fun. The next set of problems is asking you, oh, come on, it is fun.
The definition of fun.
Oh, my definition of fun is right on the money. Oh, it's really going to be a lot of fun. So verify the identity. Now, I'm going to tell you what that means. So that 6a is 2a minus b, 2a plus b, plus b minus c, b plus c, plus c minus 2a, c plus 2a equals 0. This is not an equation. I'm stating that this is identity, which means the left-hand side equals the right-hand side regardless of the value of the variables. That's what an identity means. So this is always true, no matter what the variables are. What, you go like that? That's what an identity is. 5 equals 5 is an identity. It's not an equation. So you just have to verify that this, in fact, is true, that the left-hand side is, in fact, equals 0 forever and ever. So the way you do that, you just start simplifying the left-hand side till it equals the right-hand side. But it's not an equation, so you cannot be moving things across the equal sign. Okay? Because we don't know whether that's an equal sign. That's what we're trying to verify. So you're just going to mess with one side till it looks like the other side. That's the idea. That's how you verify the identity. Sometimes you mess with both sides till they meet in the middle. Okay? So, mess with one side till you get the other side. That's the idea. So that's what an identity means. It's true regardless of the value of the variable. So, if you're given options, one side is 0, the other side is all that, which side can you even mess with? Which side can you do math to? The left side. But isn't the left side a collection of something that we love?
Differences.
Yeah, a whole bunch of them, right? The set of first two parentheses is a difference of squares. If I multiply them really fast, what do I get?
2a squared minus b squared.
And by 2a squared, I mean 4a squared. 4a squared minus b squared. Right, so the first two parentheses gave me that. Automatic. What about the next two parentheses? B squared minus c squared. What about the next pair of parentheses?
C squared minus 4a squared.
All right. So after performing the difference of squares, we got that. Can you combine like terms? 4a squared cancels with 4a squared. Negative b squared with b squared. Negative c squared. And what's left? 0. So the left-hand side turned into 0, so we're done. We got one side equal the other side. So that's how you verify the identity. You take one side, you mess with it till it looks like the other side. Okay? So therefore, this is an identity. Left-hand side identically equal to the right-hand side, regardless of the value of the variable. All variables cancel out. So you can plug anything you want for A, B, C, and it'll still come out to 0, regardless. Do you believe me on that? Let's try. Any random numbers, plug them in for A, B, and C, and it will just come out to be 0 every time. Okay? So that was okay. Well, let's try the other one. The other one is, because you have a homework due on Thursday, but the homework next week is going to be very short but borderline
Do
psychotic.
you have the homework here? Just because I just upgraded on my Canvas thing yet.
You gotta, yeah, you keep, oh yeah, I have to send it to you, right?
Yeah.
Yeah, I'll send it to you, but
Thank
get on their cases, because you should do, are you enrolled in this class? Are you even, can you log in on to Canvas or not at all?
It's because I didn't know what the password combination was, and I tried resetting the password, and it just got all kinds of mess.
Call the help desk. Yeah, they'll fix it in no time. But yeah, I'll have to remember to send it to you. I saw the email. But yeah, but you did get homework 1 from me, right? Yeah, so homework 2, I'll send it to you. But homework 3 due next week, it'll have problems like that. It'll be like 5 questions, but they're, fun questions. All right. So 3 squared plus 2 squared times 3 to the 4th plus 2 to the 4th times 3 to the 8th plus 2 to the 8th times 3 to the 16th plus 2 to the 16th equals 0.2 times 3 to the 32nd power minus 2 to the 32nd power. So somehow, whatever that thing on the left equals whatever the thing on the right. Okay? Now, you can try to plug it in your calculator, and you're probably not going to succeed. That's just really weird thing to keep track of.
Is it okay if I just start solving page parentheses?
Yeah, but I mean, you get to this, you mean by solving computing? Or foiling?
9 plus 4 plus
Yeah, but then,
7 plus 8 plus...
yeah, but then this is what, 81? And then, I already done that. It gets nuts. It's 81 squared, and that's 81 to the power of 4. That's huge. Okay?
9 to the 6.
So, but remember, so every time you feel like doing some really hardcore arithmetics, raising things to the 32nd power, we don't have to do that. That's silly. We can walk our way around it. So we can start using our little formulas. Now, remember what I told you. So this is the sum of squares, right? That's sum of squares, that's sum of squares, that's sum of squares. Do we have a formula for sum of squares? Say no. We don't, right? We don't have a formula for a squared plus b squared. We kind of talked about that. Remember taking square roots of negative numbers? You asked me last time, why don't we have one? So we don't have one. So there's nothing really I can do to the left side. But on the right side, I have a difference of two even powers. So I can think of that as difference of squares and hopefully start factoring down. So that's what I'm going to do. I'm going to start with the right-hand side and see what will happen. I'm going to copy it here. So 0.2 times 3 to the 32nd minus 2 to the 32nd. So can I think of that as a difference of two squares? Yes.
Yes.
What is being squared in the first place? 3 to what power? 16, right? And 2 to the 16, right? It's 3 to the 16 squared, 2 to the 16 squared. So I can write this as 0.2 times 3 to the power 16 minus 2 to the power 16, 3 to the power 16 plus 2 to the power 16. Using a difference of squares formula, I can split it, right? Because remember, when we do exponents, we multiply them. So 16, power 16 squared is power 32. Okay? Difference of squares. Okay, is there anything I can do with a plus?
No.
No. But I can do with the minus. Can I think of this minus as a difference of two squares? What are the exponents? What exponents am I going to get? 8. So it's 0.2 times 3 to the power 8 minus 2 to the power 8, 3 to the power 8 plus 2 to the power 8. That other one just gets copied over. Now look how things are starting to match. I have these two terms and I have those two terms, right? So something's starting to resemble the left side. You see that? So again, there's nothing I can do about the pluses, but I can still break the minus down. I can still break this one. What powers am I going to get? The fourth, right? So again, it's 0.2 times 3 to the 4th minus 2 to the 4th, 3 to the 4th plus 2 to the 4th, and then I'll copy the rest, 3 to the 8th plus 2 to the 8th, 3 to the 16th plus 2 to the 16th. Now it's even better, right? We got 3 terms to match. 4th, 8th, 16th, 4th, 8th, 16th. Do you see that? Because again, that's what we're going for. We're going for the thing on the left. So they're starting to resemble each other. Can I break it further? What can I do with the 4th power? Break it down to the squares. So I can break this one. Oops, I'm doing the magic thing. I can break this one down 0.2, 3 squared minus 2 squared, 3 squared plus 2 squared, 3 to the 4th plus 2 to the 4th, 3 to the 8th plus 2 to the 8th, 3 to the 16th plus 2 to the 16th. Now notice how now I have my entire left-hand side in my computation, right? I already have my left-hand side. See? This is what I'm going for, and I'm getting it right there, right? Well, what is this? What is this junk? So this is probably the only real computation I have to do. What is 3 squared? And what is 2 squared? And what is 9 minus 4? Just 5, right? 9 minus 4. So 5. What is 5 times 0.2? 1 What?
What?
What is 5 times 0.2? 1. Isn't that a good news that this whole thing equals 1?
Oh.
Right? This thing on the side is 0.2 times 9 minus 4, which is 0.2 times 5, which is 1. Well, 1 times anything is anything. So therefore, we're done. So these types of problems you should expect on the homework 3. Oh yeah. What?
What if the left side equals 0? Because they all cancel out.
But they don't. Because they're all pluses. Right?
The left side is all pluses, so they zero out.
But it's not an equation though, right? You just, that equal sign just means that.
Yeah, that's what I have to prove, that it's in fact equal. But you see, like, think about this. All even exponents, right? So that means no matter what, you're going to get positive numbers. Yeah, we're not canceling them. They're all positive, so it's a product of a bunch of positive numbers. The number on the left is ridiculously huge. Okay, it's a big number. But we got it to match with the number on the right. Plus. So good. We got it to work. I mean, you can, what is that number if I actually compute it? It'll be really hard to do. I mean, I can do the left side. 3 to the power 32 is whatever that is. Right? That's big. Minus 2 to the power 32. So yeah, it didn't even change times 0.2. So that's what those numbers are. What is that? Thousands. So millions, billions, 370 trillion, 603 billion. That's the number. That's what each side equals to. It's huge. But we don't care what it equals to. We know they're the same now. Fun?
So how does that equal to 1?
Oh, it doesn't. That equals to 1. The 9 minus 4 times 0.2 equals to 1. This little thing. But 1 times that is that. So that's it. But it doesn't equal to 1. It's very far from it. Right? But this little thing, because I see the logic was, you always have to keep in mind what you're trying to get. See, that's what I want. And this is what I got. So I see what I want, and then I see this extra junk here. So I just computed that extra junk, and luckily it came out to be 1. Well, 1 times what I want is what I want. Right? That's the idea. That's why I stopped here and started computing that, because I already see my goal. This is what I wanted. This is, right, that's the goal, and I was messing with the right-hand side, and I got it. But then there was an extra terms here. I just computed the extra terms. Just happened to be 1.
So
lucky.
if it's not 1,
Then it's not an identity then. Because again, if I see, okay, this is what I want, but then it's times 3, well, what I want times 3 is not what I want. It's just something else. Why? That's a beautiful question. Yes. Your homework 3 will look a lot of those, you're going to be drawing those little tree diagrams. You just keep splitting one of them. So you can always split a difference with the even powers. But you cannot split the sum with even powers. You can split the sum with cubes, but not with the squares. Okay, good. Well, yeah, the rest of this worksheet is your homework as well. Because we don't, you're not going to do it now. We didn't take a break, and you don't have enough time to do that. So, yeah. On top of your homework is good. But this shouldn't take you long. I did the hard stuff. But this is fun, right? Those problems. Good for you. All right, good.